Clawdbot is blowing up this week with almost 70,000 stars on GitHub and almost close to 9,000 forks. It is being called as the open source Jarvis. People are running it on their Mac minis, giving it access to their shell, their emails, their calendars, thinking it's safe because it's local. But they haven't just built an assistant. They have built a remote code execution vulnerability that passes the Turing test. I am Yudi, a security architect. Today, I'm going to show you exactly how I compromise your local AI assistant and steal your secrets without ever touching your network. Quick context if you haven't seen this yet. Clawdbot, which actually just rebranded to Moltbot in the last 24 hours, probably to avoid any trademark issues with Anthropic, is an open source AI assistant built by Peter Steinberg, founder of the famous PSPDF kit, sold his company for hundreds of millions, just came out of retirement to build this. What makes it different from ChatGPT, Grok, Claude, Gemini? It's not a chatbot, it's actually an agent, which runs locally on your machine. It can connect to any chat apps. It can persist memory in a vector database. It can control your browser. It has full system access and can run shell commands. It can have skills, plugins, and it is already baked with 50 plus different integrations that you can use. 2026 is the year of personal agents. This lobster is gonna take over the world. People are already calling it the AI that actually does things. It has already been featured and people have already started building using it. You can see it all over X, people sharing cool products, cool automations that they are building using Clawdbot. So let's dive in. And look, I get the excitement. This is what we have wanted since Siri launched back in 2011. But here's what I see as a security architect: an application that ingests untrusted external content and has shell execution privileges. That is not an assistant. That is an attack surface. Let me show you exactly how this breaks. So here's your setup. Clawdbot running locally, connected to email and a vector database for memory and shell access for executing tasks. Looks safe, right? It's on localhost. I send you an email, just a normal looking message with meeting notes, but hidden inside is my actual payload. Your Clawdbot does its job. It scraps the email, stores it in memory. My payload is now inside your system. You wake up and ask, hey, what did I miss today? The bot queries its memory. My poisoned email comes back as context for your answer. The LLM sees my payload, and here's the critical part. The LLM cannot distinguish between data and instruction. To the model, my malicious text looks identical to your system prompt. It's all just tokens in context window. The model complies. It's helpful, it's fatal. It executes my shell command, and your SSH keys are now on my server. Your local AI just became my remote access tool. And this is what's hidden inside the innocent email. System override, a priority flag, a fake authorization, and a curl command to send my SSH key to the attacker's server. So here is a Python script that can generate similar payloads. We wrap the command in fake XML tag. These mimic the delimiters that RAG system use. The LLM sees this and thinks it's a system instruction. And then we embed this in innocent text. Here is a meeting notes. The human sees a normal email. The LLM parses the hidden payload and executes this. This attack is called Indirect Prompt Injection. It's number one on OWASP top 10 for LLM application. Now you might be thinking, just sanitize the input, filter out the dangerous pattern. Here's why that doesn't work. LLM don't have separate channel for trusted instruction and untrusted data. Everything, your system prompt, user messages, retrieve documents, get concatenated into one context window, just tokens. The model has no way to know that text from an email should be less trusted than your system prompt. This isn't a bug to be patched. It's an architectural limitation. We fundamentally haven't solved it yet. Every defense we have tried, prompt injection detection, input sanitization, output filtering has been bypassed, usually within days. If you are running Clawdbot or any agentic AI, here's what I recommend. No root access. Never give root access. Run as an unprivileged user, except the reduced functionality. Second, sandbox everything. Docker, VM, separate machine. Assume compromise. Contain the blast radius. And finally, human in the loop. Require explicit confirmation for every shell command, every file write, every network request, no exception. Yes, this kills the convenience. That's the point. Your convenience is my attack surface till we solve this architectural gap in LLMs. Look, Cloudbot is genuinely impressive engineering. Peter Steinberg built something people have wanted for over a decade. But we are rushing to give LLM tools, shell access, file system, auth token, even before we have solved the fundamental problem. They can't securely separate instructions from data. Agency requires isolation. Until we figure that out, every helpful AI agent is a potential footgun. If you want more such security breakdowns on AI system, subscribe to my channel. I am building security tools by day and breaking AI by night. Thank you and see you all in next one. I am Yudi signing off, the LLM Architect.